I'll begin with introducing you to the omniscape SyncroSim package, which just puts a user interface, like Colin just said, on omniscape Julia, so that familiarity or experience with Julia is no longer required to run an omniscape analysis. And then we'll look at how SyncroSim makes it super easy to create and compare scenarios. So close this and we'll switch off to SyncroSim. So I'll open the SyncroSim UI, which I have here pinned to my taskbar. And the first thing we'll do is install our omniscape package by going to File and Packages. So this packages window is currently listing all the packages that I have installed in my computer. For example, STSim here, landscape change package that I know some of you are working with or have used. So to install packages, we have two ways to do it, either through the package server using this install button. So now this is a list of all the packages that we have available to install from the package server, and which I haven't installed yet. And as you can see, omniscape isn't here yet. It's as we haven't put it in the package server yet. So we'll install it in a different way, which is from File. So click on this button here, Install from File. This will open a navigation menu. I'm right on the folder that I need to be, so I'll just select the package file, which has this SSIM package extension. Select it and click Open. And this package uses Conda to manage the package dependencies. So SyncroSim will prompt us to install Conda if Conda isn't already installed. And then in my case, it's prompting me then to overwrite or create a Conda environment for the omniscape package. And since I have already installed it, I'll just click No. So now the omniscape package is installed, and we can see it listed here with the other packages that I have installed. And you might notice that some of them have, or all of them except omniscape, have a hyperlink that takes us to the documentation of the package. So that's all we have to do here on this window. So I'll just close it. And now we're going to create a new library, a new SyncroSim library by going to File, New. So in SyncroSim, library is a file with extension ssim, you can see here at the bottom, that stores all the model inputs and outputs in a format that is specific to a given package. So in our case, when we select omniscape, we can see that we have two template options to pick from, an empty library and then the omniscape example, which is what we'll select. We could edit the file name, but we'll just use the suggested one. And I'm going to save it to my documents folder, but you can use the browse button to choose another location. So when I click OK, the new library will be created based on that template, and SyncroSim will automatically open it and display it in this window, which is called the Library Explorer window. So first we'll look at the library properties by selecting the library name, right-clicking, and then selecting Properties. Move it so it's easier to see. So the first thing we see is the summary data sheet that has the name of the library, which we could edit, the display name, and it also has a description that it can include any metadata that is relevant to the whole library. And here it's just saying that this library demonstrates the omniscape SyncroSim package, and the library itself is based on the omniscape Julia example that is available on their website. So before we continue, we're just going to flip over to the omniscape Julia example to review that. So this is an example that measures forest connectivity in central Maryland. And it requires four main inputs. So the first one is a resistance layer, which is a national land cover dataset tile for 2016 for Central Maryland, which they call an LCD 2016 Frederick, Maryland, and it's nicely plotted here. The second main input that we need is a reclassification table that reclassifies the land cover classes into a resistance value. The third main input that we'll need for this example is the radius, which they set to 100, the radius of the moving window. And then the last one we'll mention is the source from resistance parameter, which is set to true, which just means that the sources will be calculated from the resistance layer based on this value, this resistance value of 1. So only the forest pixels will be considered as sources. So then omniscape is run in Julia, and it generates 3 outputs: the cumulative current flow, the flow potential, and the normalized current flow. So what we'll do is reproduce this example with our omniscape SyncroSim package. So switch back to SyncroSim now. I'll close this window because the next thing we'll look is at the scenario that already comes loaded with this library. So in SyncroSim, scenario is a collection of all of the inputs and values required by the model. So let's take a look at that scenario and the properties of it by right-clicking again and selecting properties from this context menu. So again, we have the summary data sheet. We can edit the name again if we wish, and the description that just says that this is calculating forest connectivity based on the example that we just looked at, is based on this radius of 100 pixels, and all the configurations are equal to those implemented in the example. So now we'll start looking at the omniscape package itself. So we built the package by replicating the structure and the order of parameters exactly as in omniscape Julia and their documentation. So it will be familiar to you if you've worked with omniscape before. And for this reason, we have the inputs organized into a required tab and an optional tab. But just know that if you're interested in using SyncroSim to build another package, SyncroSim gives you flexibility to organize your parameters, create, name, order tabs and variables however you wish. So let's switch to the required data sheet that lists the 3 required inputs: the resistance file, which is already loaded. But if that wasn't the case, if you wanted to load a file, you could click on the yellow folder icon, and then it will open a navigation window. You would navigate where your file is, select it, click open. And then the radius of 100, which is exactly the same as the example. And for the source file, we don't need one, as under the optional tab, source from resistance is set to yes. And then the 4th main input that we're looking at is the reclassification file or table, which is also already loaded. So this is all we need to cover here at the scenario scope. So I'm just going to close the window. And once the scenario is configured, it can be run in SyncroSim. This library is already shipped with the results for the scenario, so we can go straight into looking at the scenario results. So for the results, for each scenario, they're nested within its parent scenario, and each run is stamped with the date and the time at which it was run. So let's take a look at these results properties. Again, right-clicking and selecting properties. So first, we'll take a look at the run log for this result. There's a button here at the bottom, and it's just telling us that the simulation took 4.5 minutes to run. Just going to close that. And looking at the result properties, we can see that results are simply a copy of the parent scenario. It just has all the inputs shown that here grayed out, as well as all of the outputs organized under this results tab. In here, if you want, you could export the results using this export button, if you want to keep a copy of it elsewhere, or if you want to post-process it in another software. So I'll close this, and we'll switch to visualizing these results using the SyncroSim built-in feature for plotting charts and maps. In the case of omniscape, we just have map outputs, but otherwise the plots will be organized under a charts tab and maps tab. But here, all of our maps are displayed together. have three of them that we saw online on the website: the cumulative current flow, the flow potential, and the normalized current flow. So to visualize the results for this run, we'll first add this run to the results by right-clicking and adding to the results so that the map has something to display. And we'll look at the cumulative current flow. So we'll just double-click it to open. And here we have it displayed as we saw online. On the left-hand side, we have the color legend, which you can edit by double-clicking, making your changes, and clicking OK. Along the top toolbar, you can select the zoom feature to zoom into an area to see more details. SyncroSim also has this info mode to return information about a single pixel and your plot. For example, this pixel has a value of 102. And then to see the full map again, you can click on the Zoom Full tool to return. And we can also take here a quick look at the other two outputs from omniscape. I'll select them both and click Apply to visualize them here together. I'll just remove them so we can keep just the cumulative current flow to align with the name, but here they are. So now we have that one scenario. What we'll do next is create a copy of this scenario to create a new scenario from the reference one. So we'll right-click it, select Copy, and then click anywhere in the Library Explorer and select Paste. So in this scenario, I'll open its properties again. In this scenario, we'll just change the radius value. So we'll change it from 100 to 25. So I'll just edit the name so it reflects that, as well as the description. And then all we have to do is change the variable itself to 25 and reset. I'm just going to save this. Close the window, and we're ready to run this new scenario. So to run, you can right-click and select Run from the context menu. So it's running. What SyncroSim is doing is calling on the script that in SyncroSim we call a transformer. We coded this transformer in Python, and what it does, like Colin mentioned before, is take all of the inputs that we provided to SyncroSim, and it's preparing it and formatting it in a way required by omniscape Julia. And then it's running Julia behind the scenes. And then once Julia is done running, the Python transformer will gather the outputs from Julia and return them to SyncroSim to be visualized. Right now, the analysis running, you can see the progress at the bottom here. There's a progress bar that states 2 stages of setting up and running the analysis. And you can also see the status now as done. We have a green check mark just to let us know that there were no issues or errors. And we can also look at the run log from a different place here. So clicking on the run log hyperlink to see that this run took around 50 or 55 seconds to complete. So we close this window, and now we'll compare the results for these two scenarios that we have loaded. And this time we'll look at the normalized current flow map. So just double click it to open, and I'll make it a little bigger so we can see better. And right away, we can notice that radius had a big impact on the results, changing the connectivity pattern across the landscape. We can also use the zoom in feature again to zoom into an area, and then the pan mode, the little hand, to pan through the two maps at the same time. And here, for instance, we can see an area that shows an artifact of the 25 radius, generating these grid-like circular features in the map. And due to the importance of radius and the sensitivity of the results to radius, in a few moments, I'll show you how we can use SyncroSim to perform a sensitivity analysis on radius. So as I mentioned, the omniscape SyncroSim package has a Python transformer, and this is because Python is one of the two languages that we can use to interact with SyncroSim. So if we go to the SyncroSim website, on the download page, you can see that we have our package, our SyncroSim package to interact with SyncroSim, and a Python called the PySyncroSim package. And what these packages do, they allows us to build reproducible workflows when working with really any of SyncroSim packages, from preparing the inputs to creating libraries and scenarios, running scenarios, and doing any post-processing in your preferred language of the two. So just to conclude, I'm just going to walk you through how to use our SyncroSim to interact with the omniscape package.